Good day, everyone. We are the Group 3 of BS Psychology 1A, and we're going to discuss about the Kruskal-Wallis test and Dunn test. We will share with you the definition, uses, assumptions, and formula, and we will give you an example in real-life situation without a solution and an example with a complete solution. Please listen carefully, and I hope that after this video, you will have a better understanding of what is a Kruskal-Wallis test and Dunn test. Enjoy watching while learning.
Let us define what is the Kruskal-Wallis H-test. The Kruskal-Wallis H-test is a way of comparing three or more groups to see if they are different. It is used when your data do not meet certain assumptions required for another type of test called ANOVA. Instead of assuming that the data is normally distributed, the Kruskal-Wallis test looks at the ranks of the values in each group. This makes the test more robust to outliers, which are values that are very different from the others. The test compares the medians of each group to see if they are equal. If they are not, it suggests that at least one of the groups is different from the others. The Kruskal-Wallis test is a statistical method that compares the rankings of data from different groups to see if there are any differences between them. The test calculates a statistics called H by comparing the sum of the ranks for each group, adjusted for the sample sizes and the number of the groups to what would be expected if there were no differences between the groups. The resulting H statistics is compared to a chi-squared distribution with k minus 1 degrees of freedom, where k is the number of groups. If the p-value associated with the test statistics is less than the chosen significance level, usually 0.05, then the null hypothesis is rejected, and it can be concluded that at least one group has a different median. However, the test does not tell us which group or groups are different. Additional tests called post hoc tests are needed to determine which groups differ from the others.
Good day, sir. I am Clea Dicto, and I will be discussing the definition of Dunn test. So, Dunn test is also commonly known as Bonferroni test or Dunn-Bonferroni test. So, the Dunn-Bonferroni post hoc test is a statistical procedure used to compare multiple pairs of means or averages in a group of data. It is often used after conducting a statistical test that compares means, such as an analysis of variance or ANOVA. So Dunn's test uses mean rank, and it is the appropriate procedure following a Kruskal-Wallis test. The purpose of the Dunn-Bonferroni test is to identify which pairs of means are significantly different from each other. And the Dunn-Bonferroni test works by adjusting the alpha level or the level of statistical significance to account for the number of pairs of means being compared. This is necessary because the more pairs of means that are compared, the greater the chance that a difference between means will be found simply by chance. And by adjusting the alpha level, the Dunn-Bonferroni test helps to control for this problem, known as the multiple comparisons problem. And the Dunn's multiple comparisons test compares the difference in the sum of ranks between two columns with the expected average difference based on the number of groups and their size.
Sir, hello everyone. I will be reporting the uses of Kruskal-Wallis H-test. This test is a rank-based non-parametric test. It will be used to determine if there are statistically significant differences between two or more groups of an independent variable on a continuous or a ordinal dependent variable. Also to test the null hypothesis that all k-independent samples come from populations having equal means against the alternative hypothesis that at least one population varies. For example, you could use a Kruskal-Wallis H-test to understand whether the exam performance measured on a continuous scale from 0 to 100, differed based on test anxiety levels. Example, your dependent will be exam performance and your independent variable will be test anxiety level, which has three independent groups: student with low, medium, and high test anxiety levels. Alternatively, you could use the Kruskal-Wallis age test to determine whether attitudes toward pay discrimination, which are measured on an ordinal scale varied according to job position. Like your dependent variable will be attitudes toward pay discrimination, measured on a 5-point scale from strongly agree to strongly disagree. And your independent variable will be job description, which has three independent groups: shop floor, middle management. This test is usually we need to identify the differences.
Uses of Dunn test. This test is a method for multiple comparison. It is used as a post-hoc test to analyze the variance when the number of comparison is not large when we compare to the number of all possible comparisons. The Dunn test is not recommended when all possible comparisons are performed. It is also used to pinpoint the specific means that's significant to others. It is one of the least powerful of the multiple comparison tests and can be very conservative test, especially for larger numbers of comparison. The Dunn test is therefore best used with planned comparison and is only used as a post-hoc test when other more powerful procedures are not applicable.
For us to better understand, we begin by examining the assumptions. Therefore, when should we use the Kruskal-Wallis test? Assumption number 1. Your dependent variable should be measured at the ordinal or continuous level. Example, interval or ratio. Examples of ordinal variables include Likert scale, a 7-point scale from strongly agree to strongly disagree. 3-point scale, explaining how much a customer liked a product, ranging from not very much to it's okay to yes. Examples of continuous variables include intelligence, measured using IQ score, exam performance, measured from 0 to 100, and weight, measured in kilograms, and so forth. Assumption number 2. Your independent variable should consist of 2 or more categorically independent groups. Example of independent variables that meet this criterion include ethnicity, such as Caucasian, African, American, and Hispanic. Physical activity level, sedentary, low, moderate, and high. Profession, such as surgeon, doctor, nurse, dentist, therapist, and so forth.
I will continue the two remaining assumptions of the Kruskal-Wallis test. There are two remaining assumptions for the Kruskal-Wallis test. These are the assumption number 3 and the assumption number 4. Assumption number 3. You should have independence of observations, which means that there is no relationship between the observations in each group or between the groups themselves. So it has to be no paired samples and each participant is part of only one group. So for example, there must be different participants in each group with no participant being in more than one group. Assumption number 4. In order to know how to interpret the results from a Kruskal-Wallis test, you have to determine whether the distributions in each group, examples, the distribution of score for each group of the independent variable, have the same shape, which also means that it has the same variability. So it should be in a similar shape because it shows that it has the same variability. And you can examine the data shape using histogram. Before performing the test, ensure that these 4 assumptions are not violated, because the importance of these assumptions is to help us to ensure that we are not drawing false conclusions from our analysis.
So, to solve for the Kruskal-Wallis age test, we need to identify first the formula and what is needed in order to complete the equation. The Kruskal-Wallis test is represented by age. The formula of it as follows. h is equals to the value of 12 divided by the quantity of n multiplied to n plus 1 times to the summation of r squared divided by n minus to the quantity of 3 multiplied to n plus 1.
The formula of Dunn test is the absolute value of Ri minus Rj over the square root of n times n plus 1 divided by 12 times 1 over n plus 1 over n.
So here is an example problem with that solution that we can use Kruskal-Wallis test and Dunn test. So a medical researcher has heard anecdotal evidence that certain antidepressant drugs can have the positive side effect of lowering neurological pain in those individuals with chronic neurological back pain when administered in doses lower than those prescribed for depression. The medical researcher would like to investigate this anecdotal evidence with a study. The researcher identifies 3 well-known antidepressive drugs which might have this positive side effect and labels them drug A, drug B, and drug C. The researcher then recruits a group of 60 individuals with a similar level of back pain and randomly assigns them to one of the 3 groups, which is the drug A, drug B, or drug C treatment groups, and prescribes the relevant drug for a 4-week period. At the end of the 4-week period, the researcher asked the participants to rate their back pain on a scale of 1 to 10, with 10 indicating the greatest level of pain. The researcher wants to compare the levels of pain experienced with different groups at the end of the drug treatment period.
The problem shows an example of Kruskal-Wallis test, for as we based it on the assumptions, it shows at least 3 random samples such as drug A, drug B, and drug C. Second, the size of each sample was greater than 5, for they have recruited 60 individuals and assuming there are 20 individuals per sample. The third assumption is that the dependent variable, which is the chronic neurological back pain, is measured at an ordinal continuous level. On the other hand, the independent variables consisted of 3 categorical independent groups, such as the 3 antidepressive treatments. The fourth assumption is that there is no relationship between the observations in each group or between the groups themselves, where antidepressive treatments have no relationship with each other. Lastly, the data is not normally distributed. Since the Kruskal-Wallis test is a non-parametric test, also called a distribution-free procedure, the data used do not have to be normally distributed, in contrast to the analysis of variance. As we look at the problem, the researcher wants to compare the levels of pain experienced by the different groups at the end of drug treatment period. It shows nga ginapangita niya ang pinaka-effective nga antidepressive drugs for individuals nga may chronic neurological back pain.
So sa problem, ang gusto mo sa researcher is to compare the levels of pain experienced by the different groups at the end of drug treatment. So gin-use ta kagina ang Kruskal-Wallis test to tells us if there are differences among the said groups. We then now use the post hoc test, which is the Dunn test. Ang Dunn test, gina-determine ni if the sa mga groups are different sa other groups, because Kruskal-Wallis test doesn't tell you which groups are different from other groups. So sa problem, gamiton ta ang Dunn test para mabalaan if diin sa tatlo ka groups, which is drug A, drug B, and drug C ang different sa iban. For example, kung ang drug B gid-differ sa drug A kag drug C, or ang drug A kag B gid-differ sa drug C, etc. etc. Like sa gin-mention ka previous reporters, ang pag-use ka Dunn test parehas lang ni siya sa pag-use ka post hoc sa ANOVA.
In this part, we're going to perform a Kruskal-Wallis test. The Kruskal-Wallis test is a version of the independent measures or one-way ANOVA that can be performed on ordinal or ranked data. So in this video, we're going to have an example with a complete solution. So the problem states that 4 groups of students were randomly assigned to be taught with 4 different psychological techniques, and their achievement test scores were recorded. Are the distribution of test scores the same, or do they differ in location? The Kruskal-Wallis test has 7 steps. First, we're going to state the null and alternative hypothesis. Next, we're going to state the alpha. Then, we're going to calculate the degrees of freedom. Then we state our decision rule, then we actually calculate the test statistic, and then finally state the results and conclusion.
Step 1 for Kruskal-Wallis test is stating the null and alternative hypothesis. We must first define what is our null and alternative hypothesis in this problem. And in this case, the null hypothesis is HO, states that the scores in all four groups are the same. An alternative hypothesis, HA, states that the scores in all four groups are different. Step 2. Stating the alpha. In this problem, we will be using an alpha level of 0.05. Step 3. Calculating the degrees of freedom. Our formula for this one is df equals k minus 1, wherein k is the number of groups that you have in your problem. And in this case, we have 4, so our equation would be 4 minus 1 equal to 3.
Next, based on the information, we state our decision rule. Here we go to our chi-square table, which is what we use for Kruskal-Wallis test. We have an alpha level of 0.05 and 3 degrees of freedom. Using that information, we can find our critical value. Here, our critical value is 7.815. So, if the test value that we calculate is greater than 7.815, we can reject the null hypothesis and say that there is a difference somewhere between the four groups. If the test value is not greater than 7.815, then we will not reject the null hypothesis. Now, let's actually calculate our test statistic. Here we have our information, and what we want to do for Kruskal-Wallis test is organize our scores by rank. So basically, we want to organize them from smallest to largest. Here, we have 4 groups with 4 scores in each group, so we have 16 scores. We're going to rank those 16 scores so we can calculate the test statistic for our Kruskal-Wallis test. Here, we just take in the original scores and rank them. For example, our smallest score is 51, so that's rank 1, while our largest score is 88, so that's rank 16. So now, we have our table with our ranks. So now we can calculate our test statistic. We're going to call it H, but just basically think of it as a chi-square value. And here we have our equation for calculating that. This is a kind of complicated. 12 divided by n times n plus 1 times all the sum squared divided by n minus 3 times n plus 1. That sounds kind of confusing, but I'll show right now how do we actually get those numbers. So first, our t is our sums. So for example, the sum of group 1 is 34. The sum of group 2 is 36. The sum of group 3 is 39, and the sum of group 4 is 27. And our n is just our sample sizes. We have 4 scores in each of our groups in each of our samples, so all of our n's are 4. So now we have that, we can just plug those into the equation to solve for h. For each t squared, you know t1 is 34, t2 is 36, T3 is 39, and T4 is 27. Our big N reflects our total sample size. So while each small n is 4, our total sample size is 16. It's just 4 plus 4 plus 4 plus 4. And we just plug all of those values into the equation to find our H value of 0.8396. So now we can move on to our results. Remember, our decision rule was reject the null hypothesis if the test value is greater than or equal to 7.815. Otherwise, do not reject the null hypothesis. In this case, our value is 0.8396 because it's not greater than 7.815. We do not reject the null hypothesis. Now, we state our decision rule. Basically, what that means is that there is no significant difference among the 4 groups that we compare in this Kruskal-Wallis test. So now, we will discuss about the Dunn test. Now we want to know which of these groups are different from one another. We have to compare each of these groups one by one. For example, Group 1 and 2, Group 1 and 3, Group 1 and 4, Group 2 and 3, Group 2 and 4, and Group 3 and 4. So we have to calculate 6 different values of Q and compare them to the critical value of an alpha level of 0.05. And K is 4, so the value that we are comparing to all of the Q value is 2.639. So let's begin by comparing groups 1 and 2. We'll start with the hypothesis. So for the null hypothesis, we have the mean rank of group 1 is equal to the mean rank of group 2. For the alternative hypothesis, we have the mean rank of group 1 is not equal to the mean rank of group 2. We will use the formula and substitute it, and we get the value of 0.5941, which is less than the critical value of 2.639, which means that we do not reject the null hypothesis. So we will just do these steps to the rest of the groups, and here are the Q values. We can notice that only the Q2 and 4 and Q3 and 4 are greater than the critical value. Therefore, we must reject the null hypothesis, and this means that the mean of the ranks are different. Therefore, out of these groups, Group 3 and 4 were significantly different. So that ends our discussion about the Kruskal-Wallis test and Dunn test. I hope you learned something. So, in order to assess what we have learned, please answer the activity projected on the screen.